Hello and welcome! It's been again a long time since I released the last video, but sometimes life happens and the hobby has to wait. Anyway, here we are and I'm very glad to have you on my channel again. Today I wanted to share something with you what I hope is quite interesting. If you saw my last video months ago, maybe you remember that I started with restoration of a Packard Bell 486 PC. A nice and compact machine with some interesting and not so common parts. It would be unfair if I wouldn't tell you how this journey continued. The biggest problem with it was the heavily damaged mainboard after the battery spilled all of its electrolyte over the board. The damage was quite substantial and this mainboard was completely dead. After a lot of hours of work and with the help of a microscope, I eventually was able to get it back to life. Well, kind of. I made a mistake not to test it completely. I briefly used my compact flash card with an XT IDE adapter to see if it boots into DOS, and as it did, I called it a day. It looked okay at that point, and since I wanted to make an archaeology of the original hard drive later anyway, I thought that would be also a good opportunity for some intensive tests. So I added a coin battery as a replacement for the old leaky one and decided to continue with preparing the case, drive and so on for the final setup. That was the initial plan for this video, but after I assembled everything and turned the system on again, I realized that it is extremely slow. The good news was that it was working, just very slow. The CPU was detected as a 486DX without an FPU, which is basically an SX, but at least it was reported to be a 33 MHz CPU, which was right, and though it was crawling like it would be a 16 MHz 286. My first idea was that the turbo mode is off. Maybe you remember that the PCs of that age could be slowed down by switching the turbo off, so old clock-sensitive software could run at more appropriate speed. Many games like Digger, Wing Commander and so on required that, and this machine looked like it would run in deturbo mode, which set it back by 10 times to a level of an early AT. Unlike most PCs of that time, this Packard Bell has no physical turbo button, but it is possible to switch the turbo mode by using a common key combination Ctrl-Alt+ for turbo on and Ctrl-Alt- for turbo off. And as I tried that combination, I heard the PC speaker beeping high-pitched when trying to turn turbo on and low-pitched trying to turn turbo off. However, that didn't change anything in regards of system speed, and this was the time where I understood that this could be another interesting repair video once again. To be honest, I had no clue where to start searching, and unfortunately I also didn't have enough time for an intensive investigation. I had to step away from the hobby for the most of the time, but every now and then I still made my measurements and tried to exclude various culprits. I couldn't find anything wrong. I suspected the issue to be around the turbo circuitry, but the problem was that there is no standard implementation of turbo and every manufacturer did it in a different way. There are three ways which I saw so far. First is the reduction of the main clock. This is more common for 286 and 386 CPUs. But changing the CPU clock on the fly can be tricky and end up in stability issues. That's why this solution is not very popular, especially on 486. The second way is to trigger a CPU hold signal regularly to slow it down. And the third way is to deactivate the cache somehow. This solution is more common for 486 CPUs and is often used in combination with other methods. The control of turbo is often handled inside of the chipset. That's why my gut feeling told me that the defect could be in the chipset itself. That would be quite unfortunate, but without board schematics or at least the chipset documentation, it was hard to tell what exactly was wrong. I didn't find any chipset documentation, and furthermore I had less and less time to continue my investigation, so I had to put this project aside for a while. Weeks passed and suddenly one generous viewer of my channel reached out to me and offered a huge hardware donation. Most that parts were mainboards from scrapyard, some were in good condition, others heavily damaged and only good as donors for replacement parts. But all in all, a great pile of topics for future videos, I hope. Accidentally, one of the boards which was in that pile was a Packard Bell PB430. here on the right. It is a slightly older version of the PB430 on the left, which was originally in that machine which I was trying to restore. The layout of both mainboards is very similar, and they both obviously fit in that case. The holes are all located in the same places. The ISO slot and all the onboard ports and connectors are also aligned. Both boards use the same chipset ACC Micro 2168. The first obvious difference are the memory slots. As you see, the PB410 has only one memory slot, where the PB430 has two of them. This might feel like a huge improvement on a PB430 over the PB410, but it is not as huge as it seems. Both boards have 4 MB of onboard RAM, and with additional 4 MB or 8 in total, that would be more than enough for a 486. If not, I have 16 MB modules as well, which bring the system up to 20 MB in total. So back in the days where large memory modules were expensive, this could be a problem, but today just one memory slot is not an issue anymore. The next difference is the graphics chip. The PB410 has a headland video chip, where PB430 has a Cirrus Logic one. I personally prefer Cirrus Logic chips on systems of this age, since they work quite fast and compatible. In this case, the chip itself is not the only difference. As you see, it has two memory chips with 1 MB video memory in total, and the headland, on the other hand, has only 512 kilobytes. Both video chips should be connected through the VESA local bus to the CPU, so I guess they both shouldn't be a bottleneck for the CPU, but so far I have no experience with this headland HT216 video chip, so I don't know how it holds up against the Cirrus Logic. Important is also that on this board there is only one video memory chip with only 512 kilobytes. The memory can be extended to 1 MB either by soldering another memory chip directly onto the board or using these expansion sockets. On the PB430, on the other hand, there are already two video memory chips on board with 1 MB total video memory, but it also has two expansion sockets for up to 2 MB total video memory. By the way, in my last video I told that these sockets are proprietary, and I was corrected in the comments. These are standard sockets for such zip video memory chips, and I was even contacted by Carlos, a viewer of my channel, with his project for replacement for those chips. But maybe this is a story for another day. The point is that the PB430 with its Cirrus Logic GD5428 video chip has more video memory out of the box, which would give us higher resolution and color depth. And it's nothing what can be ignored. By the way, performance-wise, in this case, the amount of video memory doesn't make any difference, especially in DOS games. But the memory is not the only difference around video circuitry on these boards. Another interesting difference is the video output quality. All Cirrus Logic video chips since CL-GD5401 contain integrated RAM DAC, which is responsible for the conversion of digital RGB signal into analog VGA. The headland, on the other hand, has this external RAM DAC, which is often not quite as good as the integrated solution like in Cirrus Logic chip. External RAM DACs are fine for CRT monitors, but often produce vertical stripes on TFT displays, which I use due to the limited space. This is one of the reasons why I usually prefer Cirrus Logic-based video cards of that generation. So, as I said, both boards would fit into that case, but I would prefer PB430 over PB410 only because of the video chip. Otherwise, the boards are very similar, even most of the chips are in the same places. But currently it's not the question of what I would prefer. As you remember, the PB430 on the left is running very slow, and the PB410 on the right, well, let's go a bit back in time. As I got this board, it was not only very dirty, but also the battery was still installed and leaked heavily over a huge area of the board. As I inspected it first, it didn't look as I would be able to rescue it, but it was too difficult to tell definitely if it already crossed the point of no return. So I decided at least to remove the battery, neutralize the electrolyte with white vinegar to stop the reaction, wash the board and take a closer look after cleaning once again. After the board was clean and dry, it looked even worse than at the first glance. Of course, the board didn't boot at all, And I wouldn't be me if I wouldn't at least try to get it back to life to some extent. At that point I didn't realize which rabbit hole I was approaching, but I hoped to get it running to be able to compare the turbo functionality with the PB430. And like with the PB430 on this board, most traces around the multiplexer IC were heavily damaged and I had to remove it to be able to see what's underneath. This time I tried my best to keep the SMD pads in place. The problem is that the electrolyte from the battery reacts with the solder joints and ends up as a thick layer of oxide. The longer the solder is exposed to the electrolyte, the more of it transforms into, well, salt. The salt doesn't melt even with higher temperatures, and also fresh solder doesn't stick on it. It is very hard to desolder such oxidized solder joint. I was lucky, and with Dremel and a very fine rasp tip I could scratch the oxide off the solder joints. Now I could add some fresh solder and eventually remove the ICs without damaging the pads. As I said, a lot of traces were damaged, most of which had teeny tiny micro cracks which were not even visible through the microscope. I could just measure that they were broken traces. I don't want to show each one of the traces, but there were dozens. I don't know even how many of them I had to fix. This time I decided to avoid hanging bodge wires completely and fix the traces by soldering wires directly onto the remains of the old traces. Therefore I used the same fine Dremel tip again to remove the oxide from the traces, tinned them afterwards and soldered wires on top. After a couple of days of work, measuring, testing and repairing the traces, this is how the board looked like. Turned out to be quite clean. It's even hard to tell that there are so many repair traces. I was happy at least with the visual results, but the best was that at this point I could convince the board to show some kind of live sign. The postcode analyzer finally showed some codes and the PC speaker beeped 3 times. I assumed that this has to be a memory error, so equipped with the DRAM datasheet I started to measure the signals on the data bus. After turning on the system, all data pins of the DRAM chips went high and then showed some kinds of activity, except the 4 pin of the U68 IC. That one remained always low. Of course, I had no schematics for this board, so I was kind of blind. However, the memory ICs are usually connected through some transceivers 74LS245 to the bus. So I started to check such transceivers pin for pin, which of them are connected to which DRAM ICs. I found pretty fast that the named pin of the U68 memory chip was not connected to any of those transceivers, and it was hard to see the traces under the ICs and which one goes where. Actually, I was hoping to get this board running and use it maybe as a hint what could be wrong with the other one, but on the other board the memory was working fine, and nobody said that I can't use that one as a hint to repair this board as well. So I grabbed the other board and found that the named data pin of the memory chip should go to the bus transceiver U52 down here. Back to the PB410, I saw that the connection was clearly interrupted. That was a good hint, and after a long search with the multimeter and microscope, I finally found a nearly invisible microcrack in the trace. Here you can see how the trace is interrupted as I follow the trace. And here under the microscope you can hopefully see the crack in the trace. I don't want to show you every trace which I found to be broken like that, but it was a huge pain to find all of them, and I compared the two boards PB430 and PB410 all the time to find out what has to go where. This was almost as good as to have a schematic. After the memory and all the other traces were fixed, the board complained about the real-time clock initialization. I didn't find any more broken traces, so I decided to replace the Dallas RTC chip with one of the benchmark ICs which I use in my RTC module project. If you don't know that project, feel free to watch my video about that. After a lot of work, I couldn't believe my eyes, but this totally dead Packard Bell PB410 suddenly showed the post screen and started to count the memory. That was one of those wow moments which I love so much and why I do all this stuff. So I added a CR2032 battery holder, so the BIOS would keep the settings, inserted the XT IDE adapter and booted the system into DOS to finally be able to investigate how turbo is working on this mainboard. The machine booted with its full speed. If you remember, the PB430 board showed around 16 points in landmark speed test, and I was very glad to see over 150 points on this PB410 board. I pressed again Ctrl-Alt- to turn off turbo. The low-pitched sound played and nothing has changed. The system kept running at full speed. I tried a couple of times to turn turbo on and off and, well, nothing has changed. It is so unbelievable. Now I had two very similar boards, one PB430 with turbo probably always off and one PB410 with turbo probably always on. I could not believe what I got after all that work. However, that was still something positive. It would be much worse if both boards would run at low speed, for example. Now I had something in my hands what I could at least compare. And what I found is quite exciting, but it is a bigger topic which I would like to talk about in a separate video. I promise you that you will not have to wait as long for that one. I'm already working on it. So please join me soon if you are curious to know more about turbo functionality on such a machine. So far, I hope you enjoyed this video. Sorry once again that it took so long to make it. Thank you for watching and goodbye.